This is a quick review of compound probability and tree diagrams. In this lesson, you will learn how to find the probability of compound events by creating a tree diagram. So let's review. List all the possible ways that Chris, Aaron, and Sam can place in the upcoming race. So as we start to list it out, we just have to start figuring out the orders that are possible. So let's say if Chris comes in first. Chris comes in first, then Aaron, then Sam. Or Chris could come in first, and then Sam second, and Aaron's third. And then we just repeat that process for the other two. We have two events where Aaron comes in first, then Chris, then Sam, and then another event where Aaron comes in first, then Sam, then Chris. And then finally, we have scenarios where Sam comes in first, and then we have the other two boys switching in terms of who comes in second and third, giving us a total of 6 outcomes. This is an organized list. But problem with an organized list is it can become really big. So for example, if we were given tiles, T-A-M-E, and I would ask you to list out all the ways that those tiles could be placed in order, you end up with 24 different ways that could happen. And this can be overwhelming for some kids. And it can cause us to feel or cause us to perhaps make a mistake along the way. So when it comes to big events or events that would result in a lot of different possibilities, organized lists is not the way to go. Instead, we would use a tree diagram. So let's think about this. What is the probability of getting green, blue, and red in that order out of a bag that has one green marble, one blue marble, and one red marble? Well, we could list it out just like we did at the organized list, but let's create a tree diagram. Tree diagram shows you how it could happen by a visual sense. So if we put our hand into the bag, there are 3 paths we can lead to, either red, green, or blue. And then after that, each of the resulting paths can be broken up into 2 more paths, where red can lead you to blue, or red can lead you to green. And then green could lead you to blue, or green could lead you to red. And then finally, blue could lead you to green, and blue could lead you to orange. And then each of those resulting paths would end up with 1 more path from each that would account for the remaining pieces in the bag. So we end up with 1, 2, 3, 4, 5, 6. The end of the tree shows us how many possibilities there are, how many possible outcomes. So we look back to our question. What is the probability of getting a green, a blue, and a red in that order from pulling out of the bag? Well, the probability would be, since there's only 1 path that allows that, 1 out of 6. In this lesson, you've learned how to find the probability of compound events by creating a tree diagram. Let's do some guided practice. Sarah tosses 3 coins, one after the other. What is the probability of tossing at least 2 tails? So for this one, I created a tree diagram that showed all of the scenarios that could start. So here's our first toss, our second toss, and our third toss. And at the end, I just listed out which ones, what the combination would be in that order. And when I listed them out, I found that there were 4 possibilities out of 8 that would end up with at least 2 tails. So the probability is 1/2. Quick quiz. A coin will be tossed 3 times, one after the other. What is the probability that the result will have 2 heads and 1 tail in any order? Again, I made a tree diagram branching out. I end up with my 8 possibilities. And it ends up being that there are 3 where I could have 2 heads and 1 tail in any order out of the 8 possible outcomes. So it is 3/8. Show all possible arrangements of the letters in the word TAM using a tree diagram. If each of the letters is on a tile and drawn at random, what is the probability that you will draw the letters T, A, M, E in that order? So I tried to create the tree diagram the um, on the slide, but it became so large, I just ended up listing them out here. So sometimes even then, a table might be another possibility, which we're going to talk about in another video. But ends up being that there is only one way for that to happen out of a possible 24. So the probability of getting um, TAME in that order is 1 out of 24.